In this video, we will look at how to solve linear equations when we have variables on both sides of the equal sign, or when we have brackets, or when both of those concepts are combined. So we will start off with looking at variables on both sides. So we know that our goal is to isolate for x, which means we need to get all of our variables on the same side before we do anything. So whenever you see a scenario like these first four examples, all we're going to do is a little bit of a swap. Let's get all of the variables on the same side of the equal sign and all the constants on the other. So I like to do a double swap. So let's say you like to have your variables on the left side. I'm going to bring the 3x to the left, and at the same time, I'm going to bring the negative 8 to the right. So both of these terms are going to cross over the equal sign, which means we have to switch our signs as they cross the equal sign. So the 7x is fine where it is, but the 3x, when it moves over, it becomes negative. And the negative 8, when it goes to the other side, becomes positive 8. Once you've done that, it's really back to basics. So I am going to collect my like terms here. 7x minus 3x is 4x. And now we just have a one-step equation. So I need to get rid of the 4. The 4 is attached to x by multiplication. So I'm going to divide both sides by 4. So I have x on the left, and then 8 divided by 4 is 2. And there we are. And then we can do a quick left side, right side check. And this check will be slightly different than the 1 and 2 step equations because we do have variables on both sides of the equal sign. So on the left side, I have 7x minus 8, and on the right side, I have 3x. Wherever I see the x, I'm going to replace it with the 2 that we just found. So 7 times 2 minus 8. 7 times 2 is 14, and when I subtract 8, I get 6. Let's see what happens on the right side. I'm going to replace the x with a 2, and 3 times 2 is 6, and they match. So I am confident in my work. All right, let's try the next one. Again, x is on both sides, constants on both sides. So let's swap things. Let's bring the negative 4x to meet the 3x, and let's take that 11 and make it join the 88. So 3x is fine. The negative 4x moves over, so it becomes positive. The 88 is fine because it's not moving, but the 11 moves, so its sign changes to negative. Let's simplify. 3x plus 4x, I have 7 x's in total. 88 subtract 11, that's 77. And now again, that final one step. 7 is attached to x by multiplication. Let's divide both sides by 7 because that's what we're trying to get rid of. And 77 divided by 7 is 11. Let's see if it works. So on our left side, we have 3x plus 11. And on the right, we have negative 4x plus 88. So 3, and then instead of x, I'll put 11. So that's 3 times 11 is 33, plus the 11 is 44. And you can completely skip this step if you want and just put this into your calculator to get the 44. And the next one, negative 4 times 11. Negative 4 times 11 is negative 44, and when I add on the 88, I get 44 as well. So I'm confident and I can move on knowing I got 100% on this question. Okay, so how about you pause the video here, try number 3 on your own, careful when you're swapping to switch those signs, and then come back to check your work to see if you're making mistakes, where are they happening. All right, the 3x goes to the left, the negative 7 to the right. The 2 stays negative, the 3x becomes negative because it moves over. The 13 is fine the way it is, but the negative 7 becomes positive. And now negative 2x minus 3x is negative 5x. Be careful there, there's potential for mistakes. And then 13 plus 7 is 20. Now, final step, super repetitive here. Make sure you didn't just divide out 5, but negative 5, so that your final answer was negative 4. And you know, if you put positive 4 or anything else, a left side, right side check doesn't catch where you made the mistake, but it will catch that you made one. And that would just mean go back and try again. So negative 2, and then instead of x, I put negative 4. You can plug this all into your calculator. Your calculator will do 8 minus 7, which is 1. Let's see what happens on the right side. 3 times negative 4, well, that's negative 12. And when I add on the 13, I get 1, and I am happy. All right, why don't you pause again, take note of any mistakes you might have made, and really be careful here. So try this one out, and then come back to check your work. All right, I'm going to bring the negative 10x to the 11 and the 2 to the 9. Now, you might notice that I'm bringing everything to the x because I found that most people like putting the variables on the x, but you are more than welcome to take those variables to the right side if it seems easier to you or it makes more sense in a certain question. So here I'm going to have negative 11x, the negative 10 turns positive, and then 9 subtract 2 because I had to switch the sign for the 2. Now I am left with negative 1x equals 7. I am not done. Negative x is not the same thing as x. I have to divide both sides by negative 1 to give me negative 7. If you chose to bring your x's to the right, you could have actually avoided this whole dividing out the negative, but you know, this is fine. My left side, 2 minus 11x. My right side, 9 minus 10x. Okay, so we're going to do 2 minus 11 times negative 7, which is 2 plus 77, which is 79. And let's see what we get on the right side. 9 minus 10 times negative 7, which is 9 plus 70, which is also 79. So that's great. And that's it for variables on both sides. Let's bring in the brackets. And really, the only difference with the brackets is you have to do some distribution, and then you're back to the basics. So in this first example, we have 24 equals 6 times x minus 1. Let's get rid of that bracket by bringing the 6 in. So the 24 stays as is, and then 6 times x is 6x, and 6 times negative 1 is negative 6. Now this is literally just a two-step equation. So my variable here is on the right side. I'm not going to bother moving it over, and I do just want to show you it's okay to keep the x on the right. So instead, I'm going to bring the negative 6 to the other side so that it becomes positive 6. And I have 24 plus 6 is 30. And now let's get rid of that 6 that is attached to the x by multiplication by doing the opposite, which is dividing both sides by 6. So really, after you get rid of the brackets, it is very repetitive and very similar, hopefully. So my left side, right side check. The left side has a 24. The right side has 6 times x minus 1. But instead of x, I'm just going to put the 5 in. So 5 times 1 is 4. 6 times 4 is 24. So yay, that was correct. So in the next one, we do have a negative 3 in front of the bracket, so we do have to be very careful with the sign when we do our distribution. But why don't you pause the video here, try it out, and then we'll check. All right, so when we do the distribution, we should have negative 6x minus 9. This is where there's potential for mistakes. Some people might have written plus 9, so be careful. Equals 33. I'm going to bring the negative 9 over so that it becomes positive 9, so 33 plus 9, which gives us 42. And like pretty much every final step, we need to get rid of the negative 6, so let's divide out the negative 6 from both sides. So we do get negative 7 as our final answer. Now, you will notice that our equation has gotten a little bit more complicated, which means our left side, right side check might just be a bit annoying to do with full-on bed mass and simplifying. So in this scenario, you know, I would probably just go to my calculator, just A, to be safe and to be faster. So -3, I open up a bracket, 2 times -7 plus 3, close my bracket, and I got 33, which is my right side, so I'm happy. All right, if we look at our final two examples here, we do have brackets on, or we have multiple brackets. In number 7, we have brackets on both sides, and number 8, we just have 2 on the same side. So really, let's get rid of the brackets and let's see what happens. So when I distribute the 5 in, I have 5x plus 5. When I distribute the 4 in, I have 4x minus 16. Now it's just one of those scenarios where we have variables on both sides. And what did we just do? We swapped. So now that we got rid of the brackets, just pause the video here and finish this off on your own. When you swap, this is the swapping I'm doing. So the 4x becomes negative when it joins the 5x. The 16 stays negative, but the 5 becomes negative when it moves over. So I end up with 5 minus 4 is 1, so 1x, which is perfect. And negative 16 minus 5 is negative 21. Okay, my left side, right side check is going to be a little bit more involved. So I have 5 and then negative 21 plus 1, which again, 5 bracket negative 21 plus 1 in my calculator gives me negative 100. And on the right side, 4 times negative 21 minus 4, that becomes 4 times negative 25, which is also negative 100. So perfect. All right, our final one, we have multiple brackets. They are on the same side, and you have to be very careful with this -5. So pause the video here and just get rid of the brackets and then come back to check your signs before you move on. Okay, so the 2 goes in, and you should have 2x and then plus 4. And when the -5 goes in, you should have -30 and then positive 10x equals 22, because you have the -5 times the -2. 2 negatives make a positive. Okay, and at this point, you know, I have the variables on the same side already, and I also have 2 constants on the left, so I like to simplify this a little bit and collect my like terms before I think about any swapping. So I have the 2x and the 10x, that's 12 x's in total, and then I have 4 minus 30, and that's negative 26. Okay, now it's a 2-step equation. Okay, bring the 26 over, it becomes positive. And when I add those numbers, I do end up with 48. And now, that same final step, divide out the 12, and I do get positive 4. Now our left side is going to be quite involved here, so I am actually going to bleed into the right side, but let's see. I have 2, and then the brackets 4 plus 2 for x plus 2, and then minus 5, 6 minus 2 times my x, which was 4. This one is very long, so I'm definitely going to my calculator to save time. So 2 bracket 4 plus 2 minus 5, open bracket 6 minus 2 times 4, close my bracket. And I got 22, which is perfect because that's what my right side was as well. So, you know, even if I didn't show that step, I could have gone to my calculator and just done it on the side. I wouldn't have had to written anything, you know, unless it was asked of you. But it's a nice way for you to check your work. All right, so that's it for variables on both sides and brackets. So again, if the variables are on opposite sides, do a swap, changing signs. If you have brackets, get rid of them with distribution. And then after that, it just becomes a nice 1 or 2 step equation like before.